Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
We're here live at Castle Elementary School with the Castle STEAM Academy for today's Science Challenge. Today on Do
Well, good afternoon and welcome to Do the Math. I'm Michael.
And I'm Susie. Here at Do the Math, you can call if with your homework questions in Bakersfield at 636-4357. From San Luis Obispo or other outlying areas, you can call 1-866-636-6284. You can email your questions to dothemath@kern.org, and you can watch online at dothemathonline.net. You can also look for us on social media, Facebook, Instagram, Twitter, and YouTube.
All right, well, we do have phone tutors available until 5:30 most Tuesdays and Wednesdays throughout the regular school year. As a reminder, if you phone in from San Luis Obispo County and we do one of your math problems on air, you'll automatically receive ice cream, courtesy of our friends at Doc Bernstein's Ice Cream Lab. We do have a very special guest in studio. We'll be chatting with him in just a little bit. We'll be going back out to Castle Elementary School, home of the STEAM Academy, and talking with possibly the superintendent of the Panama Buena Vista Union School District, as well as somebody from Chevron. And hopefully we can find out a little bit more about what's going on with the STEAM Academy out at Castle Elementary. But before we get to all of that, let's first take a look at today's Math in the News. All right, so yesterday we all had a day off from school because of Martin Luther King Jr. holiday. And did you do anything interesting with your day off?
No, but I would like to tell you what my grandson said.
Okay.
This was a couple years ago, but we went out to dinner and he was asking us why we celebrated Martin Luther King holiday. And we said, well, Martin Luther King had a dream that all children, no matter which color they were, could go to school together. And he said, well, then why do we stay home on Martin Luther King Day? So I thought that was a good question.
There you go. That's kind of a clever little point right there.
Yeah.
Anyway, back in 1964, Martin Luther King was the then youngest person to ever win a Nobel Peace Prize.
Yep.
All right. And his hometown of Atlanta wanted to throw him a party. All right. And so we just got a photograph here and just one of his quotes: "The time is always right to do what is right." You know, some people are like, well, I'll do it sometimes or whatever, but I mean, to always do the right thing. So anyway, the hometown of Atlanta is where Martin Luther King was from. They wanted to have a party for him because the youngest Nobel Peace Prize, and you know, he's from there, his family's there and stuff like that. Atlanta in 1964 was still segregated though.
Okay.
All right. So they wanted to have a party, but there were some people in Atlanta that were like, we don't want to have a party because we're still segregated, so we're not going to let this party happen, or if it does, we're not necessarily going to make it a big event. So there are some major corporations and companies in Atlanta, and one of them is Coca-Cola. Okay, they're an international company and they happen to be based in Atlanta. So the CEO of Coca-Cola heard this rumbling about not having a big party for, you know, one of their own, and he said, no, we're going to have a party for him, and we're going to have a big party. So it was because of the CEO of Coca-Cola pushing the right button, saying, listen, you guys, you don't know what you're talking about. We're going to have a party. those of you that decide not to come, that's fine, but we're going to have a big shindig. So they did. And because of that, we have what we're going to look at today as far as the math is concerned now.
Okay.
So, I had to tie this all into math somehow.
Right.
Because we had the day off, Martin Luther King holiday. At the time, youngest person to win the Nobel Peace Prize. Party eventually happened in Atlanta because of the CEO of Coca-Cola. Coca-Cola has a pH number of 2.8.
Okay.
And some students might go, well, I don't even know what you're talking about with the pH. So, acidic and basic are two extremes that describe a chemical property, chemicals. Mixing acids and bases can cancel out or neutralize their extreme effects. A substance that is neither acidic nor basic is neutral. So, water. Okay. The pH scale measures how acidic or basic a substance is. The pH scale ranges from 0 to 14. So we can see right here that we've got our pH scale, and it goes from 0 to 14, and how you can write what they are as far as using exponents and then in decimal form. And then we've got one more right here where it can show students just some basic examples of where different materials would lie on this scale. So we can see that water is right in the middle, it's neutral, okay? The highly acidic things have the lower numbers, and like I said, Coke has about a 2.8. So it's about like vinegar, all right? So it's in between like a 2 and a 3. It is strong. And then you've got things like soap and bleach and baking soda, that are more on the alkali or basic end right there. And that is today's Math in the News and how we tie all of that together to having a day off yesterday. So, in studio with us right now, we have Justice. And Justice, how are you today?
Good.
And why don't you let everybody know where you go to school and what grade you're in?
I go to school at Ronald Reagan Elementary, and I'm in 5th grade.
How long have you been at Reagan?
6 years.
So you've been there ever since kindergarten?
Yes,
All
I
right.
have.
So how's 5th grade going?
It's okay.
It's okay? Nothing great, nothing too bad about it?
Yeah.
All right, well, since it's just okay, how about if you tell me the best thing so far about 5th grade?
Our teacher coming back from when she was sick.
All right, so your teacher was out. Obviously, that causes a little bit of disruption in class, but now she's back, right?
Yeah.
And everything's going well?
Yes.
Good. Well, you know what? That is always an important thing, to have continuity in the classroom and to have your regular teacher back. Now, one thing that you guys are working on right now is working with fractions, correct?
Yes.
All right, well, let's get you to the board. We won't waste any more time. Head on over to the board. I'm going to give you guys a problem, and you kind of explain to Susie how you would solve the problem, and if you need some help, she's right there with you. All right? So, Susie, why don't you write the problem on the board?
Okay.
And let's go 1/4 plus 5/8. So you're working with unlike denominators right now, Justice. So explain to us how you would solve the problem.
You would have to change the 1/4 to 2/8,
Correct.
and then you would add the 2 to the 7 to the 5 to make it 7.
So go ahead and write it out for us and how you get to that.
That's correct. How did you know that 1/4 was 2/8?
Because if you multiply 4 times 2, it would equal 8. And what you do on the bottom, you do on the top.
Good. So this part right here is 2/8, right there. Excellent. So you
All
know
right.
how to do it.
So you did nice on that one. So let's go ahead and make this a little different now. All right. So let's leave the 5/8. That's
Okay,
fine. Just
5/8.
rewrite it again. So
Okay.
5/8. And now let's add 7/4.
Okay. Did I put it up too high? Nope, I don't think so. You can write it again down here if you want. How after you change it. What,
So
what do
first thing
think
you want to
the-
do, see, I threw you a little curve right
Yeah.
there, right? So you still want to get a common denominator. So do that first.
It'd be 8 is the common denominator.
That's correct. 8 is the common denominator. And how do you get 8 from 4?
You multiply it by 2.
Right, so I'm just going to write that part in for you. Okay, now how about if you write a new problem, 5/8 right here, plus, okay, and then what do we have there?
You'd have
It's okay to have the improper. The improper is perfectly okay.
14 over 8,
That's
but
right.
you'd have to simplify it.
Not yet. When we get to the very end, we'll simplify it. Okay, so put 14/8. You don't want to simplify till you get to the end because you need 8s and you need to add. Okay, so now you can figure out what it is. Deb, you're doing good.
And then
You want to do it in your head or up there?
I'm doing it in my head and
Okay.
then writing it down.
He's pretty good at the mental math. That's right. Very good.
So now that he's done it mentally, so explain, because there's students learning this for the first time, how did you get 2? Where did you get 2 from?
19, it goes over 8 twice evenly, but that would have to be 16. And then I got that 2 from the how many times it goes into it, how many times 8 goes into 19. And then I got 3 as the remainder, and I put it on top.
Yeah. So did you know that there was 8/8 is one whole, right? So you have 8/8, then you have another 8/8. That's the 16/8. That gives you the 2 wholes and then 3/8 left over.
Yeah, that's how I did it.
There you go.
thinking.
Nicely done. A little math in there as well. 636-4357 is the phone number. We do have phone tutors available until 5:30. Right now, we're going to go out and about with Devin at Castle Elementary.
Hey, thanks a lot, Mike. Back here at Castle Elementary School with Panama Buena Vista Superintendent Dr. Kevin Silberberg. We've had the opportunity to be here a little bit to set the show up today, and it really is a remarkable transformation what's happened here at Castle. Kind of walk us through what this school has undergone as part of the Castle STEAM Academy.
The concept behind the school was birthed basically in a meeting that what could we do with a school? Basically, it wasn't doing things better in the district. We can do that fine. But this was all about what could we do to do new things? And so by searching locally, by searching throughout California, we found some schools where it really was good to take a trip and see what other schools are doing. We did that, and we formed in our mind just a vision of what the instructional design would be of the school, as well as the experience for the kids. From that came, well, what would the instructors look like? What would the furniture look like? What would the environment look like? What would the day look like? In fact, what would the summer look like? What would after school look like? And I'm proud to say that the administrative team and the teachers here at Castle took that, and in such a short time, they've developed such a wonderful environment for our kids, and we're already seeing great results from that.
The design of everything is phenomenal. I mean, if you're a kid who's been in a very traditional classroom for your entire academic career,
Right.
You walk through here, you've got floor-to-ceiling windows, you've got dynamic seating areas, everything looks like it could be dry erase to really work on ideas and move around. Really, to kind of break down that firewall for science-based learning and careers down the line.
And in the back of our mind is how do we replicate this and how do we sustain that? We have to be able to do that, not just for a couple of years and for this school, but for many years in many schools. And so we want this to really affect how schooling is done in the district and for this school and many of our existing schools, and that's already starting to happen. So I'm excited about this being our research and development, if you will, and really practicing some things, getting some things right, getting some things wrong, improving on that, and then watch out the rest of the district.
You've had a lot of strong partnerships to really build this as the kind of pilot for this type of model. We can bring in one of those partners as well. Joining us from Chevron, Adam Alvidrez. Adam, thank you for joining us this afternoon. So tell us a little bit about the collaboration between Chevron and Panama with the work here.
Sure, absolutely. So it's a great day to be at Castle Elementary STEAM Academy. Chevron is one of many partners, but when the opportunity came to us to evaluate, we knew that they were going to create an environment that was conducive to hands-on learning, project-based learning. We want the kids to tinker, invent, make stuff. We want them to fail and learn from what they did wrong and improve on certain aspects. So at the end of the day, what we're trying to do is simulate a real-world environment. And so Chevron came in and we helped with some maker space tools and to get the kids going, and we're proud of the partnership and we hope to continue that as well.
I want to say it was last year or so, we had an opportunity to meet with some of the engineers at Chevron and talk a little bit about some of the math that they do on the job that ties in directly with, some of the middle school math. We looked at the Pythagorean theorem as a model for power output, for example. How does that scale in with, the elementary levels now? Because, we're not working with middle schoolers at Castle. We go a little bit further down the grade spans.
Well, I think having tools to problem solve is really important. So as what you saw with Quinn, one of our electrical engineers, is that we're creating that sense of relevancy and rigor at the same time. That relevancy can happen at any point in time, kindergarten, 7th grade, 8th grade. So what we're really trying to do is to get students to realize that they can do anything in life. STEAM careers are plentiful down the road, and so we realize that there's a lot of talent in Kern County. We want to continue that momentum to get them excited about those opportunities.
Well, it's a wonderful site for us to jump in today with our Science for Kern Science Challenge. In fact, I believe it's already underway. So let's head on over to see Michelle and see how the team over there is handling their challenge. Let's figure out what they've got on their plates this afternoon. They look like they're so busy. Let's ruin that right now and see if we can disrupt things a little bit. How's it going, everybody? Hi. Let's say hi to Miss Michelle over here. Hi. So you're already kind of elbow deep with your work, and I use that as kind of a pun because you guys are building something very similar in that nature. So tell us a little bit about our science challenge today.
Our Science for Kern Engineering Challenge today is to design a robotic arm, much like you would see on the Mars rover. The students have in their bags today, the materials that they'll be using are a couple of pieces of cardboard, brass fastener, they have some pieces of straw, a piece of string, and ultimately in the end, to meet the criteria of the challenge to be successful today, their arm has got to have some sort of finger at the end of the hand, if you will, which we'll use a paper clip for that, and they'll have to be able to pick up the cup that has the paper clip attached to it.
With the added challenge of having the television cameras in the room as well. But, when you were describing that, you could see a lot of the groups, hearing the challenge again, they kind of had that chin out saying, I think I have an idea. I think we're gonna try something out here. And it's a great opportunity to play around with something that is very familiar. The idea of robots is very enticing and very intriguing. And yet you look at the materials handy and it is very low tech. And so how do we take a low tech material base to a high tech concept? And so that's going to be the engineering challenge here.
That is the ultimate challenge today. And the students have had a chance to have some discussions in their small groups to do some preliminary planning. But now it's time to actually open up your bags and begin trying out your plan. Take your materials out and start building. Let's see what you can do to get started.
So they got right into those bags and those materials hand on. The conversation has already started. You can hear the murmur. The collaboration is underway. We're going to come back a little bit later on in the program to check on the progress of our groups, get some questions answered about some ideas that have come into play, and we'll see who is tackling this challenge head on right off the bat.
Absolutely. We'll have some discussions when they come back about progress and whether or not their robotic arm is actually working as they hoped it would. And we'll be talking about modifications and revisions that they might need to make to be successful.
So right now, we're going to send it back to the studio with Mike and Susie and our special guest, and come on back here to the Castle STEAM Academy to check in a little bit later on in the show. For now, Mike, back to you.
All right, thank you to Michelle and Devin out there, and also a big thanks to Dr. Kevin Silberberg and Adam Alvidrez for joining us at the Castle STEAM Academy this afternoon. We do have phone tutors available until 5:30 this afternoon. Right now, we've got 5th grade student Justice in studio. You ready to get back to work?
Yes.
All right, back on over there, young man. So first time we did some addition with unlike denominators. Now we're going to do some subtraction. All right, so Susie, here we go. Let's go 4/5 minus 1/2. So Justice, I know that you're able to do a lot of this in your head, mental math, but kind of talk your way through it and write it for students learning it, and then I'll give you another problem right after this.
Okay. So you'd have to change this to 5/10 and that to 8/10
Good. How did you know that it would be 10?
because they go the least common denominator would be 10, and you could also do multiplication.
Very good. You could do 5 times 2 is 10. Okay, good. All right, so how are you going to change 4/5 to tenths?
Times 2, so
Here, I'll write that part for you, okay? So times 2 over 2, all right?
and then for this you do 5.
Times 5 over 5. Okay, and now you can write the new problem, okay?
And it equals 3 over 10.
Excellent. Do you know why it's okay to multiply by 2 over 2? 2 over 2 is 1, and 5 over 5 is 1. You can always multiply something by 1 and it will stay the same, right?
Yes.
So I've got a question for you, Justice, because you turned those into tens. Is there anything else you could have turned them into? Could I have done 20?
Yes,
But why did you opt for 10 instead of 20 if we could have done that?
because it was the lowest.
There you go. That's exactly what I was looking for. So the LCD, the lowest common denominator. All right. All right. So go ahead and erase the board. And let's see. Let's make this. Oh, let's see. What should we do here? Let's start off with a mixed number.
Okay.
4 3/5 minus 1/3. So the same thing, get a common denominator, and then, because there's actually 2 different ways you can go about this, but the way you feel most comfortable.
How
So-
about you do it, and I'll explain while you're doing it. Okay?
Okay.
All right?
Lowest common, 15.
Okay, he's choosing 15 because 5 and 3 both go into 15.
And
Okay, and how did you get 5/15? It's correct, but how did you get it?
I multiplied it by 5 since that's what you do to get 15 for the 3.
Okay, very good. Good, and you didn't forget that. Sometimes people forget that. Okay.
It would be
Yep, you snuck it in. Very good. Didn't forget it. That's correct.
There you go, nicely done. Actually, you did it the easier way right then, because there are some students that would take that and turn it into an improper fraction first, but then you're gonna have to take it and turn it back into a mixed number at the end of that whole thing. So nicely done. So come on back over here, Justice, because I'm gonna need you to do some help. Okay, you're gonna help me out right now. What we're gonna do is we're going to go back out to Castle Elementary School, where the STEAM Academy is, and we're gonna take a look. So what does it look like they're doing right now?
looks like an arm.
Right, because they're supposed to do some robotic arm, right? All right, so we can see some of the groups and what they're doing right there. And it looks like they're kind of doing the same thing, right?
Yes.
Have you ever done anything with robotics yet?
Yes.
You like doing that stuff? You do it in regular class, or where you guys do this stuff?
Gate.
So you do it in gate. All right. So right now, it looks as though Michelle from Science for Kern is kind of guiding them and helping them along their way. And I know that in a little while we'll be going back out there with Devin to see exactly how they're doing and what steps they're on. But it looks like a lot of the groups are kind of doing the same thing, where they've got that long part and then they've got that one piece working at an angle. It looks like they've got a brad or something right there connecting those two things. And as always, Michelle and Science for Kern are always ready and available to come out to your school and help you guys out if you need some help with some different science activities. And all you have to do is go online, find Science for Kern. Michelle will have that information available, and it's right there at the bottom of your screen. And you can just say, hey, listen, you know, like what you guys are doing, we want to try something out, and come on out to our school, and you'll get Michelle and the band heading out your way. Hey, we do have phone tutors available until 5:30 this afternoon. We'll be back with more right after this. Today we're at Di Giorgio School, where home of the Dragons are, and today we're here to do the math! Woo! All right, this afternoon we're working with Karen, a 6th grade student. And Karen, I know that you said that you have some fog delays at your school every once in a while, right?
Yeah.
Have you ever had a snow day?
No.
No.
It's too hot over here.
It's too hot over here, isn't it? Yeah, well, you know what? During the wintertime it gets a little cool, but we don't get any snow out here, do we? Well, let's take a look at this problem we have right here. We have 4 different cities, and they happen to get some snow. City A had how much snow?
24.5 inches.
Right. What about B?
20 and 2/5 inches.
Good. And C?
17 and 3/10 inches.
Good. I'm glad I wrote nicely enough so you could read those right there. City D, we don't know how much snow they received, though. But we know that all 4 cities together had a total of 93 inches of snow. So we need to figure out how much snow they had. So how would you like to solve this problem?
We add all of these, and we subtract them by 93.
Sounds like a good strategy. Let's go ahead and start.
24, 1 half, plus 20, 10. So then
Okay. So now what are you thinking about now that you're looking at these?
you have to find the common denominator.
Common denominator. Now, for students that are just learning about fractions and mixed numbers, where is the denominator?
It's the bottom number.
Right. Okay, so what are the 3 denominators we have?
2, 5, and 10.
All right, so you need something that 2, 5, and 10 will all go into, correct? That's what you're looking for? All right. And what do you think that'll be?
10.
How do you know that so fast?
Because 2 and 5 go into 10, and
Right.
10 goes into 10.
There you go, easy enough, huh? All right, so show us what to do next.
So then you change the denominators, and whatever you do to the bottom one, you have to do to the top one. So then 2 times 5 is 10, and then 1 times 5 is 5.
Perfect.
And then you do the same thing to all the other ones. 5 times 2 is 10, 2 times 2 is 4. Then 10 times 1 is 10, and 3 times 1 is 3.
Perfect. All right, so now what?
You add them all up, so 9 plus 3 is 12 over 10, but that's an improper fraction.
Perfect.
So you have to make it proper. So 10 goes into 12 once, and you get 2 left over.
Good.
And then you add that with 24, 20, and 17. So 1, 2, 10 plus 20. I'll take
Maybe just do the whole numbers first?
it. Yeah.
Okay, there you go.
24 plus 20 plus 17. 7 plus 4 is 11. 2 plus 2 is 4, plus 1, that's 5. 5 plus 1 is 6.
So the whole numbers that you've taken so far, you added up and you've got 61. And we have this 1 2/10. So now what do you do with that?
You add them.
Perfect.
So 1, 2, 10 equal 1 minus 1 is 0. 6. And then the 2 tenths.
Okay, so you can add these. So you subtracted, I think, there. 1 minus 1, you got
Oh,
0. So instead,
yeah.
let's go 1 plus 1.
That's going to be 2.
There you go. All right, so you've got the total for these 3 cities. So what's the next step?
You gotta subtract it by 93.
Okay.
So 93 minus 62 and 2/10. You have to turn this into a improper fraction.
We could. You could make that improper, or we could just make that a mixed number. What do you think of that? Do you know how to do that?
No.
Okay, so we're dealing in tenths, right? Before we even do that, can we simplify 2/10
Yes.
into what?
We can simplify it into 1 over 5.
Great, that's what, nicely done right there. Okay, so we're dealing with fifths. All right, so how many fifths would make a whole 1?
5.
Right, 5 fifths. So if we borrow a whole 1 from this, what will this whole number become? So let's write it over here.
It would be 92
And how many fifths?
and 5 over 5.
Exactly.
5 fifths.
Nicely done right there. So now we have 92 and 5 fifths, and we'll subtract the 62 and 1/5. Does that make it a little bit easier?
Yeah.
Okay.
1.
So now let's go ahead and do that.
5 fifths minus 1/5 is 4 fifths. Then 2 minus 2 is 0. And then 9 minus 6 is 3.
All right. So what does this number now represent?
The inches of snow in City D.
All right. So go ahead and put it up there.
30 and 4 fifths
30 and 4/5 what?
of inches of snow.
Don't forget the label right there. Now, if you had an option of living in A, B, C, or D, what city would you like to live in?
Having the City C.
Why?
Because too much snow.
Too much snow in the other ones?
Mm.
All right. Well, you know what, Karen? Nicely done. Perfect work right there.
Thank you.
All right, just a reminder, we do have phone tutors available until 5:30. Phone numbers are at the bottom of your screen periodically throughout the program. We have Justice in studio, a 5th grade student working on some fractions today. But right now we're going to head back out to Castle Elementary.
Hey, thanks a lot, Mike. Back here at the Castle STEAM Academy here at Castle Elementary School, our engineering challenge with Science for Kern is underway. The challenge has been laid out. Create a robotic arm that can pick up a Dixie cup with just a hook and manipulate it. And our groups of students have been doing a phenomenal job of working some designs together with the materials they've been given. And now's our chance to really look around and see what we've got underway so far. So I want to join with our folks over here who had an initial design with their bits of straw here on the cardboard with the fasteners. So tell us a little bit about some of the ideas you've tried out so far.
We tried taping a straw right here, but you put the string through it, but it wouldn't move. It was always stiff.
What about the design made it stiff? Because it seemed like you had the string go through these parts, and I think there were 2 others down here, right?
Yeah.
So why do you think it became so stiff to move?
Because the straw was blocking the cardboard.
Okay, so having that straw locked out made it difficult for that joint to come back and forth here. Did the fastener itself have any impact on that? Did you have to readjust that at all?
We wrapped the string around this too much.
What did you find happened when you wrapped the string around the fastener?
It wouldn't move.
So it looks like we're in our second design here, right? So what are some of the changes you've made from the first one?
actually thinking about tying the string through these 2 holes right there.
So you're going to use the holes that are present to tie that string through there to give it a little bit more support so that you can pull it and make that joint go back and forth. So we're going to check in a little bit later on to see if that strategy works out. We're going to come on over and take a look at another group. How's everybody doing over here?
Good.
So tell us a little bit about the design you have with these pieces of straw and the string, because it looks like you've decided to loop them through. Tell us a little bit about that.
We thought like that if we do this, it'll keep the string. We would be able to do like move this, so we could hook this onto there.
So was this your first design or is this your second attempt?
First.
Okay. So what were some of the conversations about what to try and what not to try? What were some things that got brought up that you decided not to do here?
Like putting another straw like right here.
So you decided to make sure that for everyone on this side that there had to be an equal one on the other side to spread out the string's tension. Okay. All right, well, go ahead and we're going to check with you guys a little bit later on here. A couple of different approaches with the same mindset, using some of the similar materials to do different things. We have some testing going on over here with this group. Wow, we have some very flexible manipulation here. Could you guys kind of walk us through our thought process?
So what we done, we like put tape like through the string right here, and we put it so it can like hold the batter. So hold it. No, hold the cup. So
On the cup phone.
There we go.
What about this? The only way we did it was because we tied it through here.
So you guys did the same thing using the holes that we've seen from one of the other groups. You use that as another place of stability to keep the string steady as you pull it up and down, back and forth. Is this the first design you've tried on this?
Yes.
What were some decisions you made as far as what to try versus some of your first ideas that didn't work out?
what do you mean?
So, like, were there things that you talked about trying that you said, well, we probably shouldn't do that? Or maybe we can do that, but add a little bit
yeah.
something.
We tried to try putting it through here, but it didn't work out because then if you do this, it won't move that much. That's why.
So you found that having the string near the fastener actually restricted the movement of the elbow joint.
And then we tried to do straight, but then that would work. That's
So
why.
that's why we put it
Yeah,
sideways and
like
put one right here because then we have another one. So the string, it'll go that way sometimes.
And what's interesting is that you didn't really use too many of these straw pieces. There's plenty of tape there to hold them down, but I think of all the groups, we've seen the fewest straws from this group so far. Only 4 of these pieces. So, I mean, that's a part of design too. Not just making something that works, but making something that works well using as little materials as possible. So it's a really interesting approach. Keep playing with that. That's our 3rd different design to do the same function with the same materials. Let's go ahead and check in with our group over here right now. So it looks like we're taking the string and we're really laying in heavy on the tape here to make sure that the straw is secure on both sides. Talk to us a little bit about this design.
It's supposed to pick up the back and the straw when the straw kept getting off, so we put tape on it more.
So your original test was functional, but it sounds like the straws kept falling off because the material wasn't as secure. So that is the redesign focus here, is making sure that the pieces stay on. What have you found worked and didn't work as far as how you've applied the tape to make everything stay? So more tape was your solution. Have you been wrapping it around, perhaps, or taping it directly onto the board, or what have you tried?
Taping onto the board.
So go ahead and continue on to this as you can start testing it with the pail. We'll check back in with you a little bit later on in the show to test this out. Final group here with Dr. Silverberg joining in with the design. So walk us through a little bit on some of the thought process behind this, because it looks like you've really made the effort to use as little of the materials as possible here. Only 4 pieces of straw.
So, what we did for this, so we tried each other's ideas, right? So, we tried my idea. My idea was to make it in like a zigzag, but that didn't work. So, and then we used Alea's idea, which was actually pretty good, and which made it do this.
So that was really interesting how you have this working so far, where it starts off back and then the scoop forward is what hooks it up, as opposed to some of the other ideas where the hook is kind of coming into the front and then the joint picks up this way. So you have a very different approach as far as like a scoop mindset on that set. But I thought it was really interesting to hear you say, we're going to try everybody's design and see which one works the best. That's engineering by democracy. It's a really interesting approach there. Wonderful. So we're going to check in with you guys a little bit later on to see how that holds up with our challenge. But right now we're going to send it back to the studio. Mike, take it away.
All right, thanks for that, Devin, out there at the Castle STEAM Academy. We do have phone tutors available until 5:30. We've got Justice in studio, been working on fractions, added, subtracted. Now we're going to multiply. You ready? All right, head on over to the board. And Justice, I will let you select the first fraction. What would you like the first one to be?
Multiplying, right? That's what we're doing. 3/8.
3/8. All right, so I'll come up with the next one. And let's make that, let's go 4/5. So explain to us how you would do that problem.
You'd have to find, oh wait, no, this is multiplication.
Good thinking.
You would multiply 3 times 4.
Okay. And that is,
12.
okay. Whoa, I don't write very well.
And then you would do it with 8 times 5.
Okay.
40.
Okay.
And that's, yeah, I think that's it.
Well, I noticed before that you're pretty good at simplifying. Can you see anything that simplifies there? Can you think of a number that goes into 12 and to 40 that we could factor out? They're both even. Do you think that 2 goes into both of them?
Yeah.
Do you think that 4 goes into both of them?
No.
Think again.
Oh, yes.
Yes. Okay, so if I did 12 divided by 4, I'll let you write now. 12 divided by 4 is
3.
Good. Okay, so go ahead and write the answer. Okay, good. Now let's talk about a different way to do it. Okay. Have you heard of canceling?
No.
Okay, so brand new. Now, we simplified the answer, right? You can actually simplify the problem itself. And so then you get to there, doing maybe just a little bit less work. Do you see how you pick a numerator and a denominator? 3 and 5, oops, don't have a common factor, but 4 and 8 do. What goes into 4 and 8?
2 and 4.
2 and 4. And you want to choose the bigger one. So 4 divided by 4 is?
2.
Think again. 4 divided by 4 is?
1.
Good.
I thought you said 4 divided by 8.
Okay. And then 8 divided by 4 is?
2.
So this is the one you were answering, huh?
Yeah.
Okay. All right. Now we have a little easier problem. Now see, 3 times 1
is 3.
Good. And 2 times 5 is?
10.
10. So we got the same answer. On this problem, we simplified the product. And on this one, we simplified the actual problem itself. Do you see that?
Yeah.
So you haven't done this before. This will be new for you? Well, you did well with it.
There you go, nicely done. So come on over here for a moment, Justice. And the reason I wanted you guys to do that is because when you start multiplying fractions, you have larger numbers. If you can simplify the numbers, multiplying it's easier, isn't it? Okay, so you can do something like, 176 over 249 times some other big number. But if you can simplify them, then you can start doing a little bit more mentally in your head right there. All right, so nicely done with the simplifying right there. We're going to go back out to the Castle STEAM Academy right now. We're just going to poke our heads in and see what those guys are doing. We can see Michelle right there working with one of the groups, and they've got their arm going. And funny how they were using they all had the same materials, but some were using all of the materials, and some just using as few as possible materials. So I don't know if they have some sort of maybe they have a little side contest going on, like who can use all of them and make it work, and who can use the least amount and still make it work. And we can see some of them testing them out right there. We'll check in back with those guys in just a few minutes. But we have you in studio, so you have added fractions, subtracted them, multiplied them. What do we need to do now?
Divide.
There you go. Back to the board, young man. Let's do the division. All right, so in your book here, let's go ahead and we'll just do one out of here. 1/4 divided by the whole number 6. So think about what you would like to do, and you've got Susie right there to help you if you get kind of stuck. All right?
Okay, let me explain something. I just want you to understand what division is. What if I had 1/2 divided by 1/4? That would mean how many 1/4 are in 1/2?
2.
That's right. Okay? And the way that the algorithm that we often use is this. We do 1/2, and then when you change division to multiplication, you change 1/4 to 4/1. Okay? So if you change this, you have to change this one. Okay? And so then you get 1 times 4 is 4, 2 times 1 is 2, and 4 divided by 2 is 2. Because, see, this one is a little harder to think about. It's harder to think about how many 6s are in 1/4. That's not very good mental, is it? But how many 1/4 or 1/2, that's easy to understand. Okay, so now before when we were doing a problem, you pointed out that we needed to, well, let's change it to whoops. Yeah, thanks. Change it to an improper fraction, like that. Do you agree? You already know that 6 and 6/1 are the same thing, right? Okay. So do you remember what I did?
Yes.
What did I do?
Kind of.
Did I change the first number?
No.
Okay. And
You changed the second.
I changed division to multiplication, and I changed the second number to its reciprocal, which would be
1/6.
good. And I bet you can do it by yourself now. Very good. So how many 6s are in 1/4? A 1/24. Okay, and that's still a little hard to think about in our head, huh?
Yeah.
All right, so let's move on to this one. This is going to be a little different, all right? So we have 9/14 divided by 2/7.
Okay. So can you rewrite the problem as,
Yes.
okay. Very good.
So now what I'd like you to do, Justice, is take a look at it And instead of just multiplying straight across, remember when we were doing that, there was a way that you could make it simpler first? See if you can do that first.
So you have to look at a numerator and a denominator. Yeah, we can see you're thinking about it.
7 and 14.
Yeah. So they're both divisible by 7, right?
Yes.
So what's 7 divided by 7?
1.
Okay, so cross the 7 out. Okay, and then 14 divided by 7 is 2. So now you have a much easier problem.
2 times 2 is 4. And then 9, but it has to
And let's
be.
see that mental math again, okay? And I'm going to show it not mental while you do it mental, okay? Very good. You got it.
There you go, nicely done. Come on back over here. Justice, wonderfully done. We've taken fractions and we've done every operation with them. We've added them, subtracted them, multiplied them, divided them. Nice work today. Did you think you were going to do all of that?
No.
Well, you know what? We're going to send you to the Bakersfield Condors for doing all of those different types of problems with fractions this afternoon, as well as a couple of other prizes thrown in there as well. Sound good?
Yeah.
All right. Hopefully you have a great time if you happen to get over to the Condors. I think they go until probably March or April or something like that, so you've got a couple of months ahead on over there. All right, 636-4357 is the phone number. We do have phone tutors available until 5:30. We're going to go one last time and see how they're doing with Devin at the Castle STEAM Academy.
Thanks a lot, Mike. Here with Michelle from Science for Kern. We are wrapping things up here at the Castle STEAM Academy at Castle Elementary with today's engineering challenge, and this is it. Moment of truth.
It is the moment of truth, and we've had some tremendous success today. And the thing that I like the most that's happened in the room today is multiple solutions to today's challenge. The students have all been successful, but solved it in each a very different way.
They don't have to depend on magic or witchcraft or anything. It's just pure science getting it done. So let's go ahead and take a look at some of our groups and put them to the test. See if their robotic arms can pick up these pails. Let's start right on over here. Are we ready?
All right.
Let's give it a shot.
Let's see. Oops. Try again. All right, so try that again. I want you to hold the arm for the test. There you go. You hold the arm and the other pole. Just gonna get it? Oh, almost. Oh, yeah. Way to go. All right, did you try kick the cup?
Yes.
Were you able to get success with kick the cup? All right, let's try kick the cup. Lay your robotic arm down. Here, let's try this way. Lay it down. All right. Now, pull.
Bit of an extra tap there, moving the arm forward as we kick it forward. So I thought that was really, really interesting to see how the placement of that joint really changed how you had to set it up to use the arm. Because you had to set that hook up under first, it looks like, then pull the string up to pick it up. So that's going to be interesting to see as we look at some of those other groups.
Absolutely. Thanks, girls.
Thank you so much. All right, let's check in over here and put you to the test.
All right, let's see. Well done.
Thank you for that support on the pail to make sure it didn't go anywhere. So you had an interesting design that we had seen with another group to kind of play around with, where you actually had to start back here and then kind of scoop it up with the hook. Was that the most successful design that you were able to build? Had you tried it the other way around, where it started up and you had to pick it up?
No.
Okay.
Was this your first original design? No. What other, how had you, because I was by earlier, how had you arranged the straws originally?
You turn that around.
Okay. And what difference did it make in turning the straw?
It really didn't bump the cardboard that much.
Okay, awesome.
Let's check in over here. Put our group over here that was working with Dr. Silverberg to the test. All right, here we go.
Oh, yeah.
Look at the extension of that elbow. You got quite a range of degrees there.
Excellent.
Phenomenal.
Excellent. Can you kick the cup?
Yeah.
I think that design is born for that challenge.
Yeah, I think so too. All right.
Wonderful.
All right.
Wonderful.
So, can you explain real quick before we move on? What's going on down here? What about this part of your design makes your robotic arm flex? What's going on down here and all that tape?
We had to use the tape to keep down the paper clip and the straw where the string goes through.
Okay.
That's so the string could use force to move the wrist.
So under here, does your string just go straight through the straw and then it's taped down here at the bottom?
Yeah.
Or do you have it coming back up in another direction?
No, it's right here. It just goes straight through and then we taped it down.
All right. Excellent.
Only 3 pieces of straw in this one, too.
Right, and
Remarkable.
very, very different design than what we've seen with the other students, but ultimately it works. It's quite effective.
Very efficient.
It's a great cup kicker.
It looks like we have our group here at the center to the test.
Oh, yay.
After this whole time. Oh.
That scoop, got the flexibility in the elbow.
Let's try that again.
Do you want one of the kids doing it? Or?
There we go. All right, so can one of the kids kick the cup?
Oh, there you go, Mariana. You do that.
Ready?
Why did you?
Okay. Oh, so this is going to be part of the next design, is to make sure that the strings stay secure within the straws. And design is a never-ending process.
That's right. That's what engineers do.
Let's go with our final group here. That's a lot of tape we got standing up here. I'm curious why. Oh, you built a goal as well out of tape. So we went all in on this. Okay.
Creativity,
They made a stadium, everybody.
All right, so.
So have we tried to pick up the cup? Yeah.
Yeah, we have.
Okay, let's check that out first. That was our main challenge, so let's do that. All right.
All right, somebody pull the string. Pull the string.
Okay.
Well, I steady here.
Now I got to see this goal in action.
Go. I did it. Do it again. Let's make a goal. All right, let's do it.
Yeah, she kicked it, but missed on the PK. So
I'm ready.
excellent, excellent. Get a yellow card on that. Wonderful work here at the Castle STEAM Academy at Castle Elementary with the Science for Kern Engineering Challenge. We have 5 successful designs here. Michelle, thank you so much again for joining us here on Do the Math. Wonderful afternoon,
My
Mike.
pleasure.
Back to you in the studio.
All right, thanks for that, Devin. Thanks also to Michelle and our friends from Science for Kern. Also, big thanks to Dr. Kevin Silverberg from the Panama Buena Vista Union School District, as well as Adam Alvidrez from Chevron. Also, biggest thanks of all from Justice right now. You had a good day today?
Yes, I
All
did.
right, you did some excellent work with all of the different things in fractions. You're our newest ambassador. I expect you to spread the good word about Do the Math. You can do that?
Yes.
All right. Hey, phone tutors are here until 5:30. Until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, the Kern County Superintendent of Schools, Southern California Gas Company, California Resources Corporation, Kern Schools Federal Credit Union, Panama Buena Vista Union School District, Bakersfield City School District, and the San Luis Obispo County Office of Education, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.